So we learned how to compare two means. We learned how to compare two proportions. We learned how to compare mu1 and mu2, p1 and p2. In this section, you learn how to compare two standard deviations, sigma 1 and sigma 2, or you compare two variances, sigma 1 squared and sigma 2 squared. So compare population standard deviation. For this, in order to compare two variances, we use what we call the F distribution, which I showed you last time. This is the F distribution. The F distribution is a skewed curve to the right. It is always positive. It requires 2 degrees of freedom. One is called degrees of freedom of numerator, and one is called degrees of freedom of denominator. As the degrees of freedom of numerator and degrees of freedom denominator come close to the number 30, your curve will resemble the shape of a bell-shaped curve. The total area under any curve is 100%, guys. The F distribution is always a positive, and all values of F are greater than or equal to 0. This value here is called the test statistic. So that's a step number 2 that we usually do. It is S1 squared, which is the variance from the first sample, and S2 squared is the variance from the second sample. But because we're going to be using technology, you don't even need to compute this by hand. Everything is going to be done using the calculator. So this is what we call the F distribution. Where else did you see the F distribution? You saw the F distribution when we did ANOVA, because when you do ANOVA, you get F equals. This is another test that requires the use of this type, just of this distribution. You don't need to sketch any curve for me or anything, but you just need to know that we will be using an F distribution. Now, if you get confused, they said, oh, well, what do I put here? Do I put like T or Z? Well, the calculator is going to give you a hint, because the calculator is going to put F equals. So you just copy what you see of the calculator and put F equals. You don't put T or Z unless if it is a T test or a Z test. So let me take you, just to an example and show you how to perform the F test comparing two variances. But before I do that, guys, let me show you the 3 different scenarios of stating the null and the alternative hypothesis when you perform, when you compare two variances. So you have sigma 1 and you have sigma 2. And these are the 3 options, guys, of stating the null and the alternative hypothesis. This is one option. And probably after I write the first one, you guys should be able to help me with the second ones. Population variance 1 is greater than or equal to population variance 2. Population variance 1 is less than. This is 1. What would be the second one? Would a student help us out here? Okay, I'll put the sigma 1 square, sigma 2 square here for convenience. What would be the signs, guys? Any response?
Greater than or equal to, and then less than.
We did that. It's already there. That's the first.
Oh, sorry. Less than or equal to, and then greater than.
Good. Okay. Now I need the third option. Just like what you learned before, guys, it doesn't change. That's why I told you, once you pick up chapter 7, well, everything is just gonna follow. That doesn't change the signs. HO must always have greater than or equal to, less than or equal to, or equal to. HA must have less than, greater than, or not equal to. So would you guys agree with me if I put equal and what? Not equal. Now, which one do you choose when I give you the problem? Well, whatever he says. If he says check that the variances are not equal, you're going to select this one. If he says check that one variance is greater than the other one, you're going to select that one. If he says check that one variance is less than the other one, you're going to select the second one, the first one right here. Okay. And let's do this one. We're going to use technology for this one. So you want using technology for a two sample F test. You want to purchase stock in a company and are deciding between two different stocks. Because a stock's risk can be associated with the standard deviation of its daily closing prices, you randomly select samples of the daily closing prices for each stock to obtain the results shown at the left. Okay. So you selected for stock A, N2 is 30 and S2 is 3.5, and then N1 stock B, 31 closing prices, and the standard deviation was 5.7. Can you conclude that one stock is a riskier investment? Assume that the stock closing prices are normally distributed. That's a condition of the test, that the two population must be bell-shaped. When I say one is riskier than the other, which hypothesis, guys, would you choose here? First, second, or third? What does the word riskier? We have two stocks, A and B. I mean, you can see what he selected here. He selected sigma 1 square equals sigma 2 square and sigma 1 square not equal to sigma 2 square. Well, when he says one stock is riskier than the other, he didn't specify which stock is riskier than the other. So we don't know whether it is stock A or stock B. So that means all we need to know that they are different from each other. If I tell you stock A is riskier than stock B, then you have to use a greater than. Stock A is less risk, than stock B, you have to use less than. But here he says one is riskier than the other, but he didn't specify. It could be A riskier than B or B riskier than A, so you just use different from. And that's what we're gonna do here. So sigma 1 squared and sigma 2 squared, sigma 1 squared, and sigma 2 squared. So that's the first step that we use right there. And since he wants to check if one is riskier than the other, so the claim must be in the alternative hypothesis. Now, after you set this one, guys, up, all you need to know that when you compare two variances, we use a test called two sample F test. F, because we're using this distribution, and I have two samples, as you can see, guys, stock A and stock B. We usually, you see there are two standard deviations here. S1 is 5.7 and S2 is 3.5. We always label the one that has a larger standard deviation with number 1 and the one that has a smaller standard deviation with number 2. So always that's the practice right here. So at alpha equals 5%, can you conclude that one of the stocks is riskier than the other? So let's check that using the two sample F test. So I'm gonna write down what we have here. HA, I'm just gonna redo the problem again so you can see how to perform the test. So two sample F tests, guys, let's get it. Go to your calculator, stat tests, right here. And then scroll up if I were you, because they're at the bottom and you can see it right here. That's the one that you haven't used. That's the last test, guys, that you haven't used in this book yet. Enter. I don't have data. I have a summary, so it's stats. You see, the calculator is prompting you for S1, N1, S2, N2. It couldn't be any simpler than that. You already have S1, N1, S2, N2. So let's enter them. S1, guys, if you don't see it clearly, it's 5.7. N1, as you can see, it's 31. S2 is 3.5. And N2 is 30. And can a student tell me which sign do I select here, first, second, or third? Okay. First, I agree. That's the alternative. That doesn't change from one test to another. Okay, I agree. The chat answer is correct as well. Enter. Calculate. You're going to get F equals, guys. You will see. See? F equals 2.65 and p-value is 0.0102. That's all I need. Which is less than alpha. Alpha is 5% here, guys. So reject HO. And if you reject HO, there is enough evidence to conclude that one stock is riskier investment. There is. I'll raise this up so you can see what I'm writing. At the 0.05 level of significance to support the claim that one stock is a riskier investment. Now, you know it should be a to support, but when you use the drop-down menu in my math lab to find, just a statement, you might not see to support, you might see to conclude. You just use that one as well, that's fine. Because here it says, can you conclude? So I'm sure the answer is going to be, it's going to have a conclude in it. It's the same thing. So at the 0.05 level is to conclude that one stock is a riskier investment. Now, which stock? I don't know. Is it A or B? I have no idea. All I know that one is riskier than the other. And the question is about one is riskier than the other. It's not asking us which one. Okay? So that's how we perform a two-sample F test. We're going to do another question, guys, together. This is the try. You try it yourself and show you how to perform the test. So let's do try it yourself. 4. A biologist claims that the pH levels of the soil in 2 geographic locations have equal standard deviations. Independent samples from each location are randomly selected and the results are shown at the left. At alpha equals 0.01, is there enough evidence to reject the biologist's claim? Assume that the pH levels are normally distributed. All right? Okay, help me out, guys. How would you state this one? He says, can you check if the standard deviations are equal? So which one is going to be from the top, guys? The first, second, or third?
Third.
Third, I agree. Other students, please feel free to participate, guys. I didn't enforce it, but I like everybody to participate in this. I will correct you if you make mistakes. And where is the claim, guys? He says, a biologist claim that the pH levels are the same, have equal standard deviation. So do you guys agree with me if I tell you that the claim should be in the null hypothesis? Yes?
Yes.
All right. If anything that I say doesn't make sense, ask me to explain again. All right, guys. As we said, we always label the one with the higher standard deviation as number 1. So I can label this one S1 and 1, and this one S2 and 2. Sometimes he labeled them for you. Here he didn't, but just follow the practice that the one that has higher S value should be labeled as number 1. All right. Let's run the 2 sample F test. That's all I have to do now. Okay. Let me show you guys. Stat, tests. Oops, sorry. Stat, tests, 2 sample. I'm gonna scroll down. Too much. It's letter E. Okay. S1, 0.95. N1, 16. S2, 0.78. And N2 is 22. Sigma 1 is different from sigma 2. That's still valid here. And let me do a draw here, guys, show you that, how that works. The first line doesn't belong there, so let me just get rid of it. You see that doesn't belong there. So clear. And then a graph. Let's see if it still show me the graph. No. Okay, I'll do it again. So stat, doesn't hurt to do it again. Scroll up. Okay. See, it's a two-tailed test, so don't be surprised if you see the p-value shaded on both sides. It's a huge p-value, as you can see. So F is 1.48, and P is 0.3973. Which is 0.3973. Now, you could have calculated S by hand, guys, if you want. It's the formula for F is this, but you don't need to. So that will be S1, which is 0.95 squared, divided by S2, which is 0.78, and then you square it. And you should, guys, get 1.48 if you do the math here by hand. So it's a very easy test statistic to calculate. So p-value is more than alpha, guys. Fail to reject HO. There is not enough evidence to reject enough evidence at the 0.01 level of significance to reject the biologist claim. And if you ask me why did I use the word reject here, because the claim is in HO. So we're saying we don't have enough evidence to reject the claim, so the claim could be correct. When you don't reject something, it is possible. You're not saying it's 100% correct, but you're saying probably it is true. There is a chance that it could be true. Okay, so this is the second example. And I have one more example in the handout that we're gonna do together before we take a break and come back to review for the test. So let me just do one more here. A medical researcher wishes to see whether the variance of the heart rates in beats per minute of smokers is different from the variance of heart rates of people who don't smoke. 2 samples are selected and the data are shown. Using alpha equals 5%, is there enough evidence to support the claim? Use your TI-84 and the p-value approach. Okay, guys, help me state the null and the alternative hypothesis. I'll just put those first of all, and all I need you to tell me what the signs are. What is it gonna be?
Equal to and not equal to.
Does everyone agree? It says check that they are different, so not equal to, exactly. I agree. There you go, and this is the claim. All right, 2 sample F tests, guys. And I leave this next question, exercise 8, for you to do it. And if you have any questions about it, you can ask me on Monday. So again, it's a 2 sample F test. Okay, let me put this, and then you're gonna see why I put this question in there. There is a good reason. I'm intentionally not using my color screen calculator because I'm trying to be just fair to all, because I know most of you don't have the color screen. So I thought probably I should pretend like I don't have it as well. So stat, tests, scroll up, 2 sample F test. All right. Okay, help me out. I need your help with this. What do I put here?
$26. Or I'm sorry, 36.
36. Mandy says 36. Lars says 36. Another student, Lucia, says 36. And you say 36. And unfortunately, that's not correct. And now you're wondering why, what is he talking about? We just did 2 similar exercises. What's different here, guys? What did he give you here? Just look, read it. If you read right here. What did he give you? S1, correct? The sample standard deviation in S2. What did he give us here? Can someone read it for me? S1 squared. I don't want S1 squared. I want S1. Yes. So how do I figure out S1? Yes. So just be very careful. Let's say he put 37 here and you couldn't compute, just the square root of 37. Just put square root of 37 and the calculator will do it. Look, I'm gonna pretend I don't know what the square root of 36 is. Look what you can do. You put second and square root, and then just put 36 here. And don't worry about it, the calculator will compute the answer. N1, 26. So this is the reason, guys, why I put this question. I put it, but instead of giving you S1 and S2, I gave you S1 squared and S2 squared, just to be careful when you do your input. You put 36 and 10, you're gonna get the wrong answer right away. S2, square root of 10. I don't know what the square root of 10 exactly is, so just put second and square root of 10. There you go. And N2, guys, is 18. And then sigma 1 different from sigma 2. And if you like to do a draw, I can do a draw for you. Be nice and clean. It's a scoot to the right. always distribution. That's the F distribution. Oh, I don't see much of a p-value. So F is 3.6 and the p-value is 0.0084. So input S1 as square root of 36, S2 square root of 10. So you get F equals, let me just put them again, guys, so you see 3.6, p-value is 0.0084, which is less than alpha. Reject HO. There is enough evidence at the 5% level of significance to support the claim that a variance of the heart rates of smokers and non-smokers are different. So the variation in the way their heart beats is different from smokers to non-smokers. And that concludes section 10.3.